Good morning to all. This is Dr. Balaji, Associate Professor, Department of ECE Care University. Today's my talk on the programmable logic devices. So the main aim of this session is every student learn the complete concepts and behavior of a programmable logic devices. After completion of my talk, every student can able to design the few programmable logic devices. If you want to design a programmable logic device, every student should know the basic concepts of a logic gate, that is the functionality of logic gates, and as well as in terms of the truth table, and should know the functionality of its Boolean algebra. See, generally the programmable logic devices, there should be consist of a array of logic gates which are connected to each other if we want to make a simple programmable IC or the programmable logic devices. Basically, these programmable logic devices are divided into two categories. The first one is the devices that can be programmed only one time. Usually we call the factory programmable logic devices. The second category we used to call the devices that can be programmed multiple times. If we want to program the n number of times, we used to call the field programmable logic devices. These two are very important for the forthcoming topics. See here, basically the programmable logic devices are divided into two categories. The first one is the factory programmable devices. The second one is the field programmable devices. Whereas the factory programmable devices again divide into two types. The first one is read-only memory. The second one is the mask programmable gate arrays. Whereas the field programmable devices are divided into three types. The first one is simple programmable logic devices. The second one is complex programmable logic devices. And third one is the field programmable gate arrays. But as per the course ASIC and FPGA chip design, here I am completely focusing on the simple programmable logic devices, again which are categorized into four types. The first one is the programmable read-only memory. The second one is the programmable logic array. Next one is the programmable array logic, and the fourth one is the generic array logic. Now we will discuss one by one. See the classifications of a programmable logic devices: simple PLD, complex PLD, and the field programmable gate array. Again, the simple PLD divided into three types: PROM, PLA, and PAL. See, the first one is the simple PLD, or the simple programmable logic devices. See, now this is a structure of a simple PLD. There should be consist of a array of logic gates such as the AND gate and OR gates, and having multiple inputs and as well as multiple outputs. So means if you want to design a PROM or PAL or PLA, that should consist of a array of the logic gates So keep in your mind. That should be the array of the AND gate and as well as the array of the OR gates only. So we will see the first one, the programmable read-only memory. See here I have given you a very clear structure of three types of devices: the programmable ROM, programmable array logic, and as well as the programmable logic array. So means if you want to design a PROM or PAL or PLA, so every one of you keep in your mind, whereas the PROM, that should be consists of a array of the AND gates and array of the OR gates. Like the PAL and PLA should have a array of the AND gates and OR gates. But whereas the PROM, that should be consists of a fixed AND gates and the programmable OR gates. Whereas the programmable array logic, that should be consists of a programmable AND gates, but whereas the OR gate should be fixed. So in terms of the PLA, that should be consists of a both AND gates and OR gates should be the programmable. See, that's the difference between the PROM, PLA and PAL logic devices. So now these three architectures are very important if you want to design any simple PLDs. Now we'll design the PROM initially. See, now this is a structure of a PROM, consists of a fixed AND gates and as well as a programmable OR gates, and should have a inputs and the possible outputs. Okay. Now if you want to design any programmable logic devices, now these two connections are important. So whether if we are using a programmable connectivity or the connections, so we need to indicate as with this symbol, that is intact fuse. If you want to give a connectivity with the fixed gate or the fixed AND gate or the fixed OR gates, so we need to connect with this dot connections only. That is no fuse and intact fuse. These two are the important connectivity of the programmable logic device if you want to design any PROM or PAL and PLA. So here we need to consider these two symbols only. That is I used to call the dot and as well as the star. Star means the programmable connectivity, dot means that is without the programmable connectivity. That's a fixed connectivity. So for example, here we have to design the programmable ROM. So programmable ROM means should have a fixed AND gates and the programmable OR gates. Here we have given one of the logic expression in terms of the three inputs X, Y, Z, and outputs are A and B. And here we have given you the main terms as 5, 6, 7 related to the A output and the main term 3, 5, 6, 7 for the second output B. But we know how to design the PROM. So if we want to design the PROM, we should have to consider compulsory the fixed AND gates and programmable OR gates. So programmable OR gates means that should be marked with the intact fuse, that is star mark. So here three inputs are there. Symbolically we used to consider the X, Y, Z. So three inputs mean the possible outputs are 8. Every one of you represent it X, Y, Z, three inputs, and the possible outputs are the 8. That is depends on the 2 to the power of n formula. That is from M0 to M7. And here the outputs are A and B. See, these two A and B outputs are connected with the OR gates, but the programmable OR gates, whereas here that is a fixed AND gates only. And now indicate the intact fuse with the given min terms. So for example, for the first output A with OR gate, that should be connected at the given min terms, that is 5, 6 and 7. So wherever the min terms are there, indicate with the intact fuse. So means that gate is a programmable gate, like 5, 6 and 7. But whereas the second output that is connected at the min term 3, 5, 6 and 7. So wherever the min terms are there, 3, 5, 6 and 7, connect with the intact fuse. So that is the design aspects of a PROM depends on the given logic expression. That's why here my conclusion for you is, to design the PROM, we need to consider the fixed AND gates and as well as programmable OR gates. Programmable OR gates means that should be connected with the star marks or the intact fuse. Thank you.